let's take this idea that multiplication can be represented by area of rectangles and run with it. So just as a quick review, here's a picture of 3 times 4. It's shown on a set of axes here, yeah, but you see a height of 3 and a width of 4 for this rectangle. So therefore the area is 12, and in fact, you see that it's really 12 square units because there are 12 individual little squares that are being covered here. Then the picture of 1 times 1 is, a rectangle of height 1, and that rectangle also has a width of 1, so that's this special kind of rectangle is a square. And then this area should be, well, how many squares are colored in this purple color? And it's just 1 square, so 1 times 1 is 1. Now, we're going to do some work in this single square, and there's not going to be enough space to see, so let me try to zoom in on the picture. And here's what we're going to do. The thing is, going back, if 3 times 4 is a rectangle of height 3 and of width 4, and then we're looking at that area for what 3 times 4 means, well, what's 1/2 times 1/3? Well, 1/2, see, 1 is from down here in the corner all the way up to this 1, and so 1/2 should only be halfway there. And so we're going to need a lot of space. The picture, the part of the picture we're going to see is very tiny, so I think it'll be helpful to zoom in to what's going on. So here I have had the computer depict a height of 1/2 and a width of 1/3, right? 1/3 and 2/3 would have been like right where my mouse is right now. So it would be helpful, I think, to zoom in just a little bit more. So we'll try this again. Okay, I've zoomed in on the picture, and there's 1/2. I mean, what I mean is, if to get 1/2 along here, imagine this was like a pizza, like a square-shaped pizza right here, where the dotted line, the big dotted line at 1 horizontally, and the big dotted line at 1 vertically. If we had a square pizza of height 1 and width 1, it's like moving along the crust on the left side and cutting once right in the middle, so you have 2 equal sized pieces here. So there's then from the bottom left corner up to where that incision mark is, or I guess it looks like a tick mark on the y-axis, that'd be 1/2, height of 1/2. Okay, and then we need a height of 1/3, a width of 1/3. So to get 3 equal sized pieces on the bottom here, I had to cut twice. So 2 cuts create 3 pieces. Okay, and so then 1/3 would be from the left corner up to where that first tick mark is. Right, so you see now 2 different color things going on here, but the lower left is that rectangle that we want. It is a rectangle of height 1/2 and width 1/3, and it's part of this bigger, outlined in blue, it's part of this bigger original square-shaped pizza, let's say, and the bigger blue thing had an area of 1. So if the big full blue square has an area of 1, then what would be the area of the small purple rectangle down here? Well, if you look at it, this little rectangle here, it's 1 piece of pizza out of a total of 6 equal-sized pieces of pizza. You see, this 1 piece is shaded, and there are these 5 more that are really identical in size to this piece here. A total of 6 pieces, and 1 piece is eaten, let's say, right? This one down here. So it's 1/6. Right? This is a picture of 1/6. It's just from a square pizza instead of from a round pizza. Let's try another example. 1/4 times 2/3. So we need 1/4 as a height this way, so not too far, just from down up to maybe I'll eyeball it to be right here. I mean, if 1/2 is right there, then 1/4 should be half of that, right? Half of half. And then 2/3 this way, meaning we'll make the 2 cuts so that there are 3 equal-sized pieces down here, and then take 2 of the 3. So here's my picture of 1/4. So there's 3 equal-sized cuts on the crust over here, so the crust has been cut into 4 equal-sized pieces vertically, and we'll take 1 of those, and I've highlighted that in blue. To get 2/3 down here, I've cut the crust down here in 2 places. That will create the 3 equal-sized pieces. That's the 3 in the denominator of 2/3. But we're taking 2 of them this way. So I've highlighted using some color red for the first 2 out of the 3 vertical strips. And so then the portion we're taking is down here that's been double colored. It's both in blue and in red, therefore it looks purple. This purple region we're taking, we're only taking the you'll notice this rectangle here, from starting from this corner, moving over 2 tick marks to here. That's where the purple ends, and then moving up. That spot is where you see sort of the 4 colors scheme of white and then red and purple and blue, kind of all meeting at that cross section of dotted lines, and then moving all the way to the left. back to, say, right on the y-axis, there's that sort of intersection on the y-axis where you see the red and the purple. So that rectangle there, that's the rectangle that has a height of 1/4 and a width of 2/3. That's the rectangle we want. And then now, so that's we want the area of this rectangle, right? So here we're using the interpretation of multiplication as being area of rectangles. But now, what is that area precisely? Here's where bringing up the pizza interpretation of fractions is again helpful. We're really taking 2 pieces of pizza out of a total of 12, count them up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of pizza. 2 out of 12, so that's the number. That's the result of the fraction. And notice how would you start with 1/4 times 2/3 and get to 2/12? Yeah, sure, this 2/12 simplifies, but that's not the thing I want to focus on right now. One more example, 1/5 times 3/4. So cut this way 4 times to get 5 equal sized pieces of crust, and then take one of those, right? 3/4 cut this way several times. You have to cut 3 times to get 4 equal sized pieces of crust down here horizontally, and then take 3 of those. So then the region we're taking is these 3 little pieces of pizza. 3 pieces out of a total of 20, so that's 3/20. So 1/5 times 3/4 is equal to 3/20. And I would like you to stare at 1/5 times 3/4 equals 3/20, and think of how could you get 3/20 now without the diagram. If you wanted to create a recipe for somebody, what would you have to tell them to do just numerically? I hope the picture helps you feel really solid that what you're saying is going to work, but it's also nice to come up with a quick recipe here. Okay, the interactive question. In the 2/5 times 3/7 picture, you should try doing this on paper on your own. First of all, how many total pieces of pizza would there be, and how many would be taken? So pause the video, answer the question. Okay, I hope you have taken the time to pause and go answer the question, and now that you've answered the question for yourself. So 2/5 to me looks like this. There are 5 due to the 4 cuts. There, and taking then of the 5 pieces of crust here, taking 2 strips horizontally, and then 3/7. I've got to make 6 cuts of the crust down here, equally spaced apart, and then that means there's 7 pieces of crust down here. In other words, if you looked at the pizza as vertical strips, there would be 7 vertical strips, equal size strips there, and then we're going to take 3 of those. So we end up taking this little region down here of pizza, and in total there are 35 pieces, but we're going to just eat 6 of them. We're taking the 6 down here, so 6 out of 35. So I think it's really important with this example. Yeah, the numbers are growing, but I've intentionally used primes so that nothing cancels out funny, so that we can try to see what's going on. How could you get 6 from the numbers 2, 5, 3, and 7? I don't think you use all of them. And then how do you get 35 from 2, 5, 3, and 7? And I don't think that getting 35 involves all of these numbers. But do you see all the pieces in place? I hope that the previous examples help us to really understand the answer to the following question. And the question is, why is A over B times C over D equal to A times C over B times D true? And the answer, this is really just taking the ideas we saw. We saw several examples that actually use numbers, and then saying, this behavior happens in general. So starting from a unit square pizza, that is a pizza with side lengths 1 and 1, cutting horizontally into B equal size pieces and taking the lower A of those B, then cutting the pizza vertically into D equal size pieces and taking C out of those D, results in overall taking A times C pieces of pizza from a pizza that has a total of B times D pieces. So this answer is very advanced, and let me say why I think it is. It involves thinking of multiplication. There's multiplication right here, right? It involves thinking of multiplication as the area of rectangles. That concept appears. And then also this idea that fractions should be thought of as pieces from a pizza. In this case, it happens to be a square pizza. That concept also appears. So this is a very advanced answer, but it's a very correct answer to this question. And you'll notice what's going on with this fraction when you do one fraction times another is, at least as a recipe form, you just multiply straight across. It's A times C, and then in the denominator it's B times D. So fraction multiplication, first of all, doesn't require a common denominator at all. So please don't waste time trying to make a common denominator. And the key thing that what is this formula really trying to say? This formula using symbols is trying to really clarify that what's going on for multiplying two fractions is you should take one fraction and another and just multiply straight across. Do not cross multiply. That is cross multiplying is a concept that appears in some other situation that we have not dealt with yet.